This is my beginning algebra course. In the next class, you're going to take part 2 of the final test. And today we're going to prepare for that exam. And part 2 of the final test is going to cover everything that we did not cover in part 1. So it's pretty much the second half of the course. So we're going to do a practice exam right now. And I'm going to give you a practice exam for the homework. So it's just like all the other tests. And so let's go ahead and get started with this practice exam. And I want you to do all these problems on your own, if you can. If you're not sure how to do it, then you can watch me start the problem. But if you start to remember how to do it, then take over. Stop the video and do the rest on your own. You're going to absorb this information much quicker if you actually engage and do the problems on your own. Now remember, you cannot pass a math exam without studying for the exam. That's the purpose for this. Don't take part 2 of the final test unless you do the practice test for homework and work with me in these problems. Go ahead and try number 1. When you come back, we'll do it together. If you don't remember how to do this, you're going to isolate the square. The square is not isolated because the -7 and the 2 are next to it. So you're going to get this square by itself. Then you're going to get rid of this 2 power by square rooting both sides. But you must write a plus or minus sign on the side opposite the variable. That's one of the most common mistakes that students make. They forget that plus or minus sign. Then you're going to solve for x and you're going to be done. So here we go. I'm going to subtract 2 from both sides. Then we're going to multiply both sides by -7, and we get 28. So now we want to get to this x here, but we can't because the 2 power, we have to get rid of that first. So we're going to do the opposite of squaring to get rid of that 2 power, and the opposite of squaring is square rooting. Now here's the part where students have trouble. They forget. You got to write a plus or minus on the other side. So that square root gets rid of the square on the left side, and we don't really need the parentheses anymore. Now we're not allowed to leave this expression as root 28 because there's a perfect square factor. Now I'm not going to show every step of this because it gets kind of tedious to show every step, but we know that 28 is 4 times 7. We break it up into 2 roots. Then the root 4 becomes 2, and we put the 7 back and the 2 together. So again, you know all that stuff from the previous classes. So I'm just going to jump into that. I'm not going to show all that stuff because we don't have enough room to show all these steps. With math, eventually you get to the point where you just start skipping steps. So you should know how to do that by now. Okay, so now we're going to isolate x, and after we isolate x, we're done. So that's all there is to it when it comes to these problems. Now, please understand that you can write the -3 on the left, like I did just now, or you can write it at the right. It doesn't really matter. So I'm just going to leave it like that because that's the way I just wrote it. So now we're going to divide both sides by -2, and you could leave the answer like that. I mean, we're pretty much done. We don't really need to go any further. But you should be aware that if you look at the answer in a textbook, it's probably going to have a slightly different form. The signs are going to be different, and it may confuse you. When you divide by a negative, you can get rid of this negative and kind of, you can change these signs in the numerator and get rid of the negative. For example, if you divide, let's say you have x minus 3, and you divide by -1. Then you can just take x and divide it by -1, you get -x. Take -3 divided by -1, and you get +3. You see, both these signs changed and the negative disappeared. Well, that's kind of the way it works here. Both of these signs on the numerator change and the negative disappears, so you can end up with plus or minus 2 root 7 plus 3 all over +2. And that's probably the way that you're going to see it if you actually had to do this problem in a textbook. and you looked at the answer, that's probably the way that they would show it. Now, this is very confusing because the plus or minus symbol didn't change at all. But if you think about it, plus or minus means it can be plus or minus. There's two answers to this problem. So if it's plus and you change the sign, then it becomes minus or negative. If it's negative, then it becomes positive. But regardless, that doesn't do anything to the plus or minus sign, you see. So that's why these signs change to plus, but the plus or minus, nothing happens to it. So if you write it like this, that's fine. But again, just be aware you may see it in this form if you look at the answer in a textbook or something. All right, so if you got that answer, good job. And now we're going to try number 2. Number 2 is a system of equations. Remember, there's 3 ways to solve a system of equations. You can solve it with graphing, which you would never do unless your teacher forces you to do it, because it's just not practical. Or you use substitution or elimination. Now, how do we know which method to use? Do we use substitution or elimination? Well, if you had an expression like this, x is equal to 4y minus 3, we would know to use substitution. Why? Because there's a letter by itself on one side of the equation. There's a letter that's isolated. X is isolated. But in neither of these equations is an x or a y isolated. So what that means is it's going to be probably easier to use elimination. You could isolate an x or a y here and then use substitution if you wanted to, but we're just going to stick with, I don't really want to manipulate the equations. I just want to work with them the way they are now. So we're going to multiply the top equation by 3, because if we try to eliminate a variable now and add these equations together, we come up with the following equation, but that doesn't do anything for us, right? Because none of the variables, neither y or x disappeared. So what we're going to do is we're going to multiply the top equation by 3. And if you know how to do this problem, don't just watch me do it. Do it on your own. Then you can fast forward and see what the answer is, just to make sure you did it correctly, but don't just watch me do it. And again, if you don't know how to do the problem, but as you're watching me do it, you're starting to remember, then again, stop the video and do it on your own. So we multiply the top equation by 3, we get 6x minus 3y is equal to 9. And then we have 5x plus 3y is equal to 24. And so now you see these are the same coefficient, but they're just opposite signs. So that means we can add them up. 6x plus 5x is 11x. And then these cancel out, and then we get 0. And over here we get 33. So we have 11x is equal to 33, and x is equal to 3. So that's one of our answers. Now I'm going to take the top equation, and I'm going to plug in the answer we just got, which is x equals 3. I'm going to plug in 3 and find y. Maybe put a little divider here. So I got that 3 from here. I'm plugging it in. So we don't have a lot of room to do all this math, and we don't have a lot of time to do the math either, so we end up with 3. Y is equal to 3. So if you got those answers, good job. On to number 3. It says, use the slope-intercept form to find the slope-intercept form of the equation of the line with slope 4 and containing the point 2, negative 2. So what this means is we're going to use this form, y equals mx plus b, to find our equation. And so we're going to plug in negative 2 for y. And please understand that there are multiple ways to do this, but it tells us specifically to use slope-intercept form. That's y equals mx plus b. So I'm going to plug in -2 for y. M we know is 4. And x I'm going to plug in 2. And we're going to use that information to find b. So just to be clear where this information came from, and we're going to use all those to find b. So if we do the math on that, we end up with you don't really have to show the steps on this because this is just, pre-algebra stuff. So now we have b is equal to -10. So now that we know that b is equal to -10, we have the y-intercept. B is the y-intercept. And we have the slope. They gave us the slope, which is 4. So we can now find the slope-intercept form. Up here in red, or yellow should I say, they say to find the slope-intercept form of the equation. So we used the slope-intercept form to find the slope-intercept form of the equation, which we're going to write now because we have the slope and the y-intercept. So again, we're going to use y equals mx plus b, plug in m, which they gave us, and plug in b, and we're done. So maybe I over-explained that, but you should be able to do that problem in like maybe 20 or 30 seconds. It shouldn't take that long. Now you might also say, well, we have the slope. They gave us the slope, and they gave us a point. So how come we don't just use point-slope form? We can just plug in our slope, the blue slope that they gave us, and the purple and green point, and then we'll be done. Well, the problem is they said specifically, again, to use slope-intercept form, not point-slope form. So I want you to know how to use the slope-intercept form. All right, on to the next problem. Find an equation of the line with the following characteristics. So again, if you think you can do this problem, go ahead and attempt it. There's actually multiple ways to do this problem. I'm going to show you two methods. One method is to use the slope-intercept form like we just did. This is probably the method that I would prefer. So we're going to plug in 5 for y because we have a y value. We're going to plug in nothing for m because we don't know what the slope is. 2 for x, and then they give us the y-intercept is 1/2. Remember, b stands for the y-intercept. So when they tell us that the y-intercept is 1/2, that means lowercase b is 1/2. That's, they told us that information. So then we just plug in, and again, this 2 went there, and this 5 came from there. So now we can use that information, or that equation, to find the slope of the line, and if we subtract 1/2 from both sides, we get 9/2 is equal to 2m. And we're out of room, so I'm going to go up here. Divide both sides by 2, and when you divide 9/2 by 2, you can think of it as dividing by 2 with that classic symbol and flip. And we get 1/2 and multiply straight across. This is all stuff that you should know by now. So then we get 9/4 for the slope. Now that we have the slope, we can easily write the slope-intercept form. Slope-intercept form, again, is y equals mx plus b. We know the slope is 9/4, and we know b is 1/2. Came from up there, and the purple 9/4, we just found that slope. So that's one method. That's one way to do it. But I just want you to know that there's another way to do it. You only have to use one method, obviously. But I just want you to know that if you wanted to use a different way, another way you could do it is you could say, okay, we have one point, but we also have another point, because if they tell you the y-intercept is 1/2, that means 0, 1/2 is also another point. And why do I know that the x value is 0 here? Well, because the y-intercept is the value on the y-axis that the line crosses, which means that that coordinate, the x value, obviously has to be 0. That's what it means to be on the y-axis. The x value has to be 0. So we need two things to graph a line. We need a point and we need the slope. The point gives us a reference about where our position is, and the slope gives the direction of the line or the steepness. So then at that point what we would do is we'd find the slope of the line and use our formula given 2 points that tells us how to find the slope of the line. And you don't have to do this, but just to show you what's going on here, I'm going to label these points. It's point 1 and point 2. So now if we plug in y2, that's 1/2, and then y1 is 5. And x2 is 0, and x1 is 2. And if we simplify that, we get positive 9/4. So we know that m is positive 9/4, and that's the same slope that we got with the other method. So that's good. Let's double check everything, make sure everything looks right. Everything seems right. So now we could write, again, the slope-intercept form and just plug everything in. We now know the slope is 9/4, and the y-intercept we knew from the beginning. That's just 1/2. So we just plug in 1/2. So there's different ways to do this. I prefer method 1, but if you prefer method 2, that's fine. But again, you only have to use one method. You don't want to waste time doing both of those, obviously. Okay, so if you got those answers, good job. Let's try number 5. Find an equation of the line with x-intercept 7. Find an equation of the line with x-intercept 7 and that is perpendicular to the line with the equation -2x minus 4 equals y. So the most important thing is to understand what we know about our line. I don't know if that's the best title, but it doesn't really matter. The line we're looking for, we know that there's a point 7, 0 on our line. Okay, how do I know that? Well, because up here it says the x-intercept. We're looking for an equation for the line that has x-intercept 7. So we know that this point is on our line. Again, remember, if the x-intercept is 7, that means the y value of this point has to be 0 because it's on the x-axis. That's what it means to be an x-intercept, is the y value has to be 0. Now, in order to find the equation of a line, you have to have a point, which we already have, but you also have to have the slope. We don't have the slope. That's the problem. We're going to use this other information here in purple to find the slope of our line. It tells us that our line is perpendicular to the line with this equation here. So maybe I'll title this other line, because this is characteristics of not the line we're looking for, but the other line that they tell us about. The other line, -2x minus 4 equals y, that's in slope-intercept form. You see, mx plus b is equal to y. Now, because it's in slope-intercept form, that means that we can see the slope. The slope is -2. So the slope of this line here is -2. The slope of this green line here is -2. Now, our line is perpendicular to the line with this equation. So that means whatever the slope of this equation, the equation of our line is going to have a slope that is the opposite reciprocal. So I'm going to write m and I'm going to write a little perpendicular symbol there. I don't remember if I did this in the actual course, but what this means is that we're going to find the slope of the line that's perpendicular to this line. So what we do is we take -2 and we flip it and we change the sign. If it's negative, it changes to positive. If it's positive, it changes to negative. So we have a negative slope, so it's going to change to positive, and we flipped it. So again, be aware that -2 can be written as -2/1, right? So if we flip it, it becomes 1/2. So that's what I mean by that. So now, this slope is the slope of our line that we're looking for. So now we're going to take that and throw it up here. So now we know the slope of the line that we're looking for, which again I should call slope perpendicular, is 1/2. So now it doesn't tell us to find any particular form. So because we have a point on our line and the slope, we can use point-slope form. That's going to be the fastest way to find an equation. Sometimes in these problems it tells you the form that they're looking for, but other times it just says find an equation. You can use any form, the most convenient form. So I'm going to plug in 0 for yp, 1/2 for m, and 7 for xp. That was pretty easy. So you don't have to do all these colors. I'm just doing this to help you with the concepts. And that is the final answer. We have our equation. So if you got that answer, good job. Now you can also write it in slope-intercept form. If you chose to do it a different way, then the answer would be 1/2 x minus 7/2. So if you did it that way, that's fine. Okay, but I prefer you do it the fastest way. Let's try number 6. Go ahead and attempt number 6 if you think you can do it. If you're not sure how to do this problem, then I'm going to get started here, but if you know how to do it, pause the video. When you come back, we'll do it together. And you can check your answer. So find an equation of the line that contains the point 9, -3. So immediately I'm going to put that in under the heading, the line we're looking for. It's very important to not get confused about what's going on here. So our line, the line we're looking for, has the point 9, -3. That's very important to understand that. That point is on the line we're looking for. But in order to find the equation of a line, we need a point, but we also need the slope. We don't have the slope. That's where this information comes in. So we're going to write other line. This other line is in, let's go ahead and write it. You don't have to rewrite the line. I'm just doing this so you can see what's going on. Don't you agree that's in point-slope form? Whoops. If I write point-slope form right under it, you can see it's in point-slope form, which means we can see the slope of the line just by looking at it. The slope of that line is -4/5. But if our line is parallel to this other line, that means the slopes are equal. So the slope of our line that we're looking for, and I'm going to draw a parallel symbol. You see that purple parallel symbol? That just means that our line is parallel to that line. So that means that our slope is also 4/5. So now we're going to throw that up here because, again, we need two things for our line. We need a point and the slope of our line to find the equation. So now we have a point and the slope. So again, it doesn't tell us to find a particular form, so we can use whatever's easiest. And what's easiest is point-slope because we have a point and the slope. So now we just plug in. If you plug in -3, it turns it to a positive. The slope we know is -4/5, and plug in your 9, and you're done. So that negative 4/5 we plugged in there, and the negative 3 came from there, but just be aware it changed signs, so don't get confused by that. And the 9 came from there. So that is our final solution. If you got that answer, good job. You should be very familiar with the things that we're going over right now. Let's double check everything. Everything looks right. Let's go on to the next problem. It says, find an equation of the line that contains the point -4, -6, and is parallel to the line with the equation -3x plus 6y equals 7. So again, let's first figure out what we know about the line that we're looking for. So it says, find an equation of the line that contains the point -4, -6. So we know that the point -4, -6 is on our line. We have that information about our line. But again, there are two things you need to find the equation of a line. You need a point and the slope. Okay, we don't have the slope. So that's where we go to this other information. So that other information I'm going to title Other Line. And that equation that they give us is in standard form. And what that means is it doesn't really give us any useful information. Remember, ax plus by equals c. That's standard form. So we can't do anything with that. We can't see the slope of that line. So in order to see the slope, I'm going to have to isolate y. I'm going to take -3x and put it on the other side. And I'll divide both sides by 6, and we end up with x over 2 plus 7 over 6. And in order to kind of see what's going on, I can change the form of that x over 2 to 1/2 x. And so don't you agree that this is now in slope-intercept form? If you're not quite sure what I mean by that, just remember slope-intercept form is y equals mx plus b. So we now have m, the slope of this line up here, is 1/2. So the slope of that line is 1/2. And because our line is parallel to that other line, that means that our slope is going to be the same. So the slope of the line that's parallel, I'm going to write parallel symbols, is also 1/2. But that's the information that we're looking for. We want that's our slope. So now we go up here and we plug that in. The slope of our line is 1/2. Now, as I'm doing this, you might be thinking, this is taking a long time. It is because I'm explaining it. But if you know how to do this problem, you don't really have to write all this stuff out. You know, I'm overthinking this. I'm overwriting all this stuff. I'm writing way more than I really need to. You should be able to solve this problem in probably about 30 seconds. Okay, so just be aware of that. I'm just doing this to explain things. You don't have to explain anything to anybody else when you're taking the test. All you have to do is show a significant amount of work, not all this, maybe like 1/3 of this work. I want you to show, converting from standard form to slope-intercept form and demonstrate that you know what the slope of the line is and you know the information you have, but that's all you really have to write. So now we have a point and the slope, and of course, as in the previous problems, the easiest way to find the equation at this point, because we have the slope and a point on the line. Again, it doesn't say to find any particular form, so now we can just plug in numbers and we have our equation. So that 4 came from there, and the 6 came from there. But again, be aware the signs change. So don't forget that, the signs change. So if you got that answer, good job. So on to the next problem. Convert the following equation to slope-intercept form. So we have point-slope form, and it wants you to convert this point-slope form to slope-intercept. So if you think you can do that, go ahead. Remember, slope-intercept form is y equals mx plus b. The characteristic that helps us remember is y is by itself. So you want to get rid of the parentheses and get y by itself. Isolate y. Go ahead and try 8, and when you come back, we'll do it together. If you're not sure how to do this problem, then first thing you do is use the distributive property, multiply 2 times x, and we get 2x. Multiply 2 times -3, and we get -6. Then subtract 7 from both sides, and we get -13. So that's it. We now have slope-intercept form because it's in y equals mx plus b form. So if you got that one right, good job. All right, on to number 9. Now we have an equation with roots. If you have an equation with roots, you want to get the root by itself. Now, in this equation, we have 2 roots. So how do you get 2 roots isolated? Well, this is pretty much all we can do. You know, each root is isolated on either side of the equation, so all we can do at this point is go ahead and just square both sides to try to get rid of those roots. So I'm going to square both sides because the opposite of square rooting is squaring. And that's going to get rid of the roots, so we have -9 plus y squared is equal to 8y. Now at this point, we can't do anything. We're stuck. Unless you recognize this equation. You see, this is a special equation, and it requires special methods to solve it. But if you don't recognize it, if you don't know what type of equation it is, you're not going to know what tools to use to solve the equation. This is a quadratic equation. How do I know that? Because there's a variable squared, a variable that's not squared, and a third number that doesn't have a variable. That's a quadratic. Now, I still can't solve the equation because in order to solve it, we have to put it in standard form. So I'm going to rearrange the terms. I'm always going to write the y squared term first, then the term with a y, and then the number without a variable. And obviously, we're going to put everything on the left side. Now, you want everything to go on the left side because you want your coefficient of the y squared term to be positive. That just makes things easier. So you have to put everything on one side. You want a positive coefficient here, and you have to order these numbers properly, or else you're not going to know how to solve this. So there's a lot of things you have to think about. You have to recognize it as a quadratic and do all those things. Now that we have it in standard form and we know it's a quadratic, we can solve with our special methods. It's y squared, so we put a y and a y. And then we ask the simple question, what 2 numbers multiply to 9, -9 that is, and add up to -8? What are 2 numbers that multiply to -9 and add up to -8? And if you said -9 and +1, you're correct. Okay, now what does this mean? Well, we changed the form of this expression to this down here. We did this because it helps us to solve. We have this y minus 9 multiplied into this y plus 1, and we get 0. So if you multiply numbers and you get 0, that means that one of the numbers had to be 0, or both of them. So in order to make the equation work, y minus 9 has to be 0, or y plus 1 has to be 0. Because that's the only way that the equation would work. So what y values would make the blue 0? Well, that's y equals 9 if we solve that equation. And the purple, to make the purple 0, we need y to be -1, solving that other equation. So we found the 2 solutions, but we shouldn't rectangle quite yet because one of these solutions might not work in the equation. So let's plug in -1. And immediately I can see -1 is not going to work because if you plug it in there, you get -8. You're not allowed to have a negative under a root. if you have a negative, that means that there's some number times itself that equals a negative. That doesn't make any sense. So I know already that y cannot be equal to -1. That's extraneous. We have to put a slash through that equal sign. Now let's check 9. If I plug in 9 up here, then I get root 72. And if I plug in y over here, I also get root 72. So that works. So we're going to rectangle y equals 9. So if you got that answer, good job. Now, the second problem is going to be a little bit more involved. We have two roots again, so it's kind of hard to isolate, both roots. We can isolate this root. Here we have that isolated, but this root is not isolated. We can't really do anything, more to isolate the root. So the only option is we're going to go ahead and square both sides of the equation to try to get rid of those roots. So I'm squaring both sides, and at the right, that's going to be really easy. At the right, it just gets rid of the root, and we're left with 1 plus 3x. Now over here, this is going to be, this is one of the most common mistakes that students make, is they think that if you have the sum of two numbers and you square, then you get the square of the first number plus the square of the second number. That's what it is. But that's not correct, because when you square, you have to use FOIL. So a lot of students would say, well, if you multiply this by itself, then it gets rid of the root, and you end up with 3x plus 4. Multiply that by itself, and you get 4, and you're done. But again, that's wrong. When you square something, it means that you're taking that number, in this case, root 3x plus 4 minus 2, and you're multiplying it by itself. So we're multiplying by another root 3x plus 4 minus 2. And so now you can see where we're going with this. We have to use FOIL. All right? So we're going to do f of FOIL. We're going to multiply the first terms, root 3x plus 4 times root 3x plus 4. Now again, when you do that, it just becomes, root 3x plus 4 squared, right? I mean, you multiply them together, then they're squared. And then O of FOIL is root 3x plus 4 times -2. So that would be -2 root 3x plus 4. And then I of FOIL would be -2 times root 3x plus 4, -2 root 3x plus 4. And then O of FOIL, -2 times -2 is +4. So let me just double check that, make sure everything's right. Everything looks good. I'm going to have to move this stuff over a little bit. So we FOILed, and that's all equal to 1 plus 3x, of course. Now, you see these blue inner terms here? Those are like terms. We have -2 apples plus -2 apples. These are the apples. I understand it's impossible to have a negative apple, but you get the point. So those are going to combine to -4 root 3x plus 4. Now we can just rewrite that other 4 and the 1 plus 3x. Now this over here, when you take a root and you square it, doesn't that just get rid of the root? That's exactly what we did over here. We had roots, right? And we squared them. So the square just gets rid of the root. So you're left with 3x plus 4. Now I know what you're thinking. You're thinking, this is complicated. Well, this actually is a pretty challenging problem. This is one of the most challenging problems on this test. So, these other root problems we're going to do are probably a little easier. Because this is the final exam, I couldn't just load the test up with a bunch of easy problems. We had to put, the more challenging ones on here. Okay, so now I'm going to subtract 3x from both sides, and these yellow 3x's are going to go away, right? So then we're just left with 4 minus 4 root 3x plus 4 plus 4 equals 1. We have a lot of 4's. Add the 4's together. Those are like terms, and we end up with 8 minus 4 root 3x plus 4 equals 1. And you don't have to show every single one of these steps. Subtract 8 from both sides, we get negative 7. I'm just showing every step, or I'm not really showing every step, but I'm showing a lot of them just because I want you to make sure you know how to do this. But you do have to show some steps. Sometimes when you tell students you can skip steps, they skip all the steps and just write the answer. Well, you have to show some work. Okay, so now it's very important to understand what happened. We had two roots, right? You see up here in green, we had two roots. We squared both sides and simplified, and we went all the way down to here, and now we only have one root. In fact, you could see at this stage, this green stage up here, that we only had one root. So it looked like we made things more complicated, but actually we got rid of one of the roots by squaring both sides. And now that we've simplified all the way down to here, we can get rid of the second root. If we rewrite this and square both sides, that's going to get rid of the second root. Sorry, my computer's going kind of slow. Because squaring is the opposite of square rooting. And so you get rid of the root, and we have 3x plus 4 is equal to, now 7 fourths times 7 fourths, just multiply straight across, 7 fourths times 7 fourths. 7 times 7 is 49. 4 times 4 is 16. So we have 49 over 16. So now it's just basic algebra. Subtract 4 from both sides, and we get negative 15 over 16. Some students may be concerned about that. Again, that's just basic arithmetic. You can go back to my arithmetic course if you want to know how to subtract 4 from 49 over 16. And then divide both sides by 3. Again, that's just negative 15 over 16 divided by 3. You can write 3 as 3 over 1. Remember, when you're dividing fractions, you just change the multiplication and flip the divisor and then multiply straight across. So we get x is equal to negative 5 over 16 when you simplify everything. But if you plug in this fraction, it's not going to work. So that's actually an extraneous solution, and there is no solution to this problem. So we're going to write no solution, and I'm going to show you why there's no solution. But let's plug in negative 15 over 16. Let's do it together, and I'm going to show you why it doesn't work. Negative 5 over 16, that was our answer. Negative 5 over 16 multiplied by 3 is negative 15 over 16. So we have negative 15 over 16 plus 4. We need a common denominator. That's 4 over 1. Multiply both sides of this fraction by 16, and we get 64 over 16. Add 64 over 16 plus negative 15 over 16, and you get 49 over 16. And that's all inside the root. Now over here, plug in the answer we got again is negative 5 over 16. Negative 5 over 16 times 3 is negative 15 over 16. So we need a common denominator because we have 1 plus negative 15 over 16. This 1 here in blue we can write as 1 over 1. Multiply both sides of the fraction by 16, and we get 16 over 16. Then we have 16 over 16 plus negative 15 over 16, and we get 1 over 16. And that's all still inside the root. Now if you simplify, root 49 over 16, that becomes 7 over 4. Root 1 over 16 becomes 1/4. And if you subtract 2 from 7/4, you get negative 1/4. And that's where the problem lies. Not possible. Okay, so on to number 11. See if you can try this problem. You want to isolate the root, get it by itself. In this problem, we can isolate the root fairly easily because there's only one root. In these previous problems, each of these problems had 2 roots. But here we only have 1 root. So first we're going to isolate that root. Once you isolate the root, square both sides and then solve for x. Try number 11a, and when you come back, we'll do it together. All right, we're back. I'm going to subtract 2 from both sides, divide both sides by 4, and then I'm going to, so I isolated the root at that point. You see, the root is by itself. So now I'm going to get rid of the root, and the opposite of rooting is squaring. So to get rid of the root, I have to square both sides. So that gets rid of the root, and I'm left with x over 3 minus 1 equals 25 over 16. Again, 5/4 squared means 5/4 times 5/4. So now we add 1 to both sides, and we get 41 over 16 is equal to x over 3. Again, when you add 1, 1 becomes 16 over 16. Then we're going to multiply both sides by 3. And then we just have 41 over 16 times 3 over 1. So then we get 123 over 16. So you got that answer, good job. Now, you don't really have to check this particular problem. Usually we plug in the answers, but in this situation, we're not going to get a negative in the root. You plug that in, you're going to be fine. Because we know the root is equal to a positive, and there's only one root in the equation, so it's probably not going to, we're not going to have an extraneous solution. And that would be a lot of math to have to do that, so we don't want to really, we don't need to worry about that. But in the next problem, we have 2 roots. So in this problem, we might have to worry about an extraneous solution. So go ahead and try part B, and when you come back, we'll do it together. If you're not sure how to do part B, we can't really isolate the roots because there's 2 of them, and there's really nothing we can do to isolate the roots. So what I'm going to do is I'm going to go ahead and just square both sides of the equation and just deal with whatever we come up with at that point. So now we get 2 root 3x minus 2 times 2 root 3x minus 2, and 2 times 2 is 4, and root 3x minus 2 times root 3x minus 2, well, that would just be root 3x minus 2 squared. You don't really have to write that. I can't remember if I wrote that in the actual class, but here we have root 5x over 3 times root 5x over 3. Whoops, I'm sorry, I'm going off the rails here. Forgot to write the other side of the equation. Root 5x times root 5x, that's just root 5x squared. You don't have to show that intermediate step if you don't want to. 3 times 3 is 9. So now, you see these expressions in yellow. If you square a root, what happens to the root? Well, it just goes away. So we have 5, and it's still multiplied into whatever's left over, so the root goes away. Up here we have 5x, the root goes away. There's a lot of different ways you could show this, and you can skip some of these steps. So now we're just going to distribute. 4 times 3x is 12x. 4 times negative 2 is negative 8. And so now we have an equation with fractions. So now I'm going to write the 12x as a fraction, and the 8 is a fraction. If we multiply both sides of these fractions over here by 9, we get 108x over 9 and 72 over 9. And we can combine those fractions at the left because now they have a common denominator. Combine those into one fraction. Now we have two fractions that are equal to each other, and the denominators are the same. So that means we can just get rid of the denominators. The numerators must be equal. Then we can subtract, or we can add, well, probably the easiest way to do it is just subtract 108 from both sides, and we get negative 103x. Divide both sides by 103, and x is equal to 72 over 103. So that is the answer. Now, we have to check our solution. We have 72 over 103. And all we really care about for this problem is to make sure we don't have any negatives in the root. As long as we don't have any negatives in the root, then the solution will be, it'll work out. It won't be extraneous. So negative 72 over 103 times 3. We need to know if that's going to be bigger than 2. As long as it's bigger than 2, so when we subtract 2, we'll get a positive number, then we'll be okay. So we're allowed a calculator on this test. So 3 times 72 equals, and then divided by 103, and we get 2.097. So when we subtract 2.097, or we subtract 2 from 2.097, we're going to get a positive number, so that works out. So that is a solution. All right, on to number 12. It says find an equation of the line through the points -5, -6, and 8, 3 in point-slope form, then slope-intercept form. Okay, remember, to find the equation of a line, you need a point on the line and you need the slope of the line. The problem is we have 2 points, we don't have the slope. So first thing we need to do is find the slope. If we have 2 points on the line, then we have to use this formula. I'm going to rewrite our points. I'm going to make that point 1. I'm going to make this point 2. And you don't have to show this. That's going to be x1 and y1 and x2 and y2. But I'm just showing you how this works. So y2 is 3, y1 is -6. And be aware that that's a double negative. So be careful of that. And we have x2 minus x1, which is another double negative. So again, be very, very careful there. So those double negatives become positive, and we have 3 plus 6 over 8 plus 5, and we end up with 9 over 13 for the slope. That looks right. So now that we have the slope of the line, and we have multiple points to choose from, we can write the point-slope form of the line, because it says find an equation. It doesn't say what form to find. So point-slope form, remember again, looks like so. And we just plug in numbers and we're done. If my computer will speed up here. What point should we choose? I'm going to choose 8, 3. So plug in our 3, our slope, and 8. So just to be sure where that came from, the purple 8 went there, the 3 went there, and our slope we got from here. So that is the answer. That's the quickest way to find the answer. There are other ways to do this, but that's probably the best way. So you got that answer, good job. Now try to find the slope-intercept form of that same line. Now there's multiple ways that we could do this, but I'm just going to start with the equation that we just came up with, which is in point-slope form, and I'm just going to convert that. Again, there's multiple ways to do it. Using the distribution property, 9 over 13 times x is 9 over 13x. 9 over 13 times negative 8 is negative 72 over 13. And all we have to do then is just put the 3 on the other side. We could do this in our head, but again, I'm just trying to show as many steps here as I can so you know exactly what's happening. So 3, we can just make it 3 over 1 and then multiply both sides of 3 over 1 by 13 and we get 39 over 13. 39 over 13 minus 72 over 13 is negative 33 over 13. So there you go. So slope-intercept form is the y equals mx plus b form. And now we have y equals mx plus b. So if you got that answer, good job. Part C says what is the slope of the line? Talking about problem number 12. Well, the slope is we found that that's the green 9/13. So slope is equal to 9 over 13. And for part D, they say what is the y-intercept? Well, the y-intercept is negative 33 over 13. So just to demonstrate that, we know that y is equal to 9x over 13 minus 33 over 13, which is y equal to mx plus b. So b is just negative 33 over 13. You don't have to show all that stuff. You can just write the answer, but I'm just showing you where that's coming from. All right, on to number 13. If you got those answers right, good job. So it says, solve the following system using the graphical method. And so this problem is forcing you to use the graphing method. So we have to use it. We would never use it again. We would never use it unless we're forced to. So what we're going to do is we're going to graph this blue equation, and then we're going to graph the green equation, and then where those lines intersect, that's going to be the solution. So now we have to ask, what form are these equations in? If they're in slope-intercept form, then we can find the y-intercept and then use the slope, rise over run, to find another point and connect the dots. The problem is they're not in slope-intercept form. So we can't use slope-intercept. That's method number 3. They're not in point-slope form either. Point-slope form has parentheses. So slope-intercept, they're not in that form, and they're not in point-slope form either. If we had point-slope form, we could again graph some point, then use the slope to graph another point. But we don't have point-slope form, so we have to use either method number 1, which is basically just choose random x values and solve for y. So pick 2 points on the line, then connect the dots, 2 random points. Or we can use method number 2, pick the x and y intercept, and then connect the dots. So now we could convert both of these into slope-intercept form, and I'd probably prefer that, but just to stick with the way we've been doing things before, we want to look at this form and then decide what we're going to do based on the form that they give us. So for the first problem, I think I'm going to use method number 1. So actually, I think I'm just going to rewrite so we know what we're doing here. So we're going to find 2 points. So let's do point number 1. I'm going to choose y is equal to -1. So if y is equal to -1, we have 1 plus -1. And I'm not going to highlight here because it's just going to take forever. Then we end up with x is equal to 0. So we ended up finding the y-intercept just by accident. So that's 1 point on the line. And I'm going to do the second point down here just to keep things, in order. And you know what? Maybe I'll call this point A and point B. So now let's let y equal, let's see, let's let y equal 2. Actually, I'm going to let y equal 3. So again, we're plugging 3 into the blue equation up there. And so we get x is equal to 4. And our point is 4, 3. So now I'm going to plot those points, 0, -1, and 4, 3. And we can go ahead and connect those dots. Might as well just do that now, get it out of the way. And I'd like you to label, that wasn't very straight. It's probably good enough, but it wasn't that straight there. So we have 0, -1. Well, I'm gonna label the points later on because I don't want the line to run in. So now we're going to plot this green equation. So you have -2x plus y equals 1. I don't really know if I have to rewrite those. So now let's do point C. And in this case, I'm going to use method 2. I'm just going to choose x and y. Actually, you know what? I'm just going to use method 1 because I don't want to end up with a fraction. So I'm going to plug in my x first. Over here, it was easier to plug in y first because x was solved for. So I'm going to try to find the y-intercept first because that's going to be easy. So we have -2 times 0, and then we have y is equal to 1. So the point is 0, 1. Then I'm going to my other point. We need 2 points to graph a line, so I'm going to call this point D. And let's see here, what can we do? I'm going to let x be -4. So we'll see if that produces a fraction. So now we're going to plug that into our equation and solve. So then we get -7. I guess that's on the graph, barely. So -4, -7. Okay, so now let's plot those 2 points. I'm going to try to use some different colors, maybe orange. So 0, 1, that's here. And then we have -4, -7. So 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7. That's all the way down here. And I'm going to connect the dots. Again, the line doesn't have to be perfect. So it looks like our solution is going to be probably there. Looks like it's going to be there, but again, the graphing method is very unreliable. So in reality, what you want to do is you want to go ahead and solve just using one of the other methods, like substitution, for example, because x is solved for. You see x is solved for up here. It's by itself on one side of the equation. So you'd use substitution. You would plug all this into x here and then solve. So we'll probably do that just to double check. In fact, part B is actually telling us to do that. But it looks like from this graph that our solution is going to be -2, -3. So we use the graphing method to solve. And we better plot these points before I forget. I want you to plot all these points. -4, -7, and 0, -1, and 4, 3. We're just double checking everything, making sure we did everything right. So that's it. But do you see how impractical this method is? I mean, you know, it takes a lot of effort, and it just takes too long. So let's actually go to part B, and part B tells us to just solve the system algebraically. So I'm going to rewrite the system. Again, the best way to solve it, we could use elimination or substitution because we're solving this algebraically, but we're going to use substitution because x is by itself on one side of the equation. So what that means is we can take the other equation and we can rewrite it, but instead of writing x, we're going to write what the top equation tells us that x is equal to. And then we'd use distribution, and we have -2 minus 2y plus y equals 1. And from that point we can go up here, and we get -2y plus y is -y, and just solve that equation, and we get y is equal to -3. And then we can plug that into the other equation. So x is equal to 1 plus -3, and so we get -2. So the answers are -2 and -3. So if we check that here, looks like we got the right answer on our graph. But you know, sometimes the graph doesn't work. You know, so that was just an example where it actually did work. But you see, we got the intersection. That demonstrates the point of how to solve using a graph. Okay, so again, just to demonstrate here, we took this 1 plus y, and we put it in here. And this other part here, that was just the other part of the equation. So hopefully that highlighting is helping you. Okay, on to number 14. So now we have an equation with fractions. So whenever we're solving an equation with fractions, you want to factor the denominators first, because that's going to tell us, it's going to give us an idea of what to do here to get a common denominator. So to see why that works, you just distribute back. 4x times 1 is 4x, and 4x times -2x is -8x squared. We can't do anything with that fraction, and it looks like we can factor out a 3 on this one here. So there's one more thing that we have to do. We have to use the -1 rule over here. Or maybe we'll... Well, yeah, we probably just want to use it over here, because we have a 2x minus 1. That's not the same thing as 1 minus 2x, so we have to use the -1 rule. So we're just going to rewrite this fraction, because we're not going to change that. And we're going to pull out a -1. So that's going to become -2x plus 1. So the signs changed in this yellow part. The signs changed because I pulled out a -1. Now, why does that work? Well, if you multiply this -1 back into here, it becomes positive 2x. And if you multiply the negative 1 back into here, it becomes minus 1. So at this point, we have a negative on the top of that fraction and on the bottom. So they just kind of cancel each other out. So we're kind of, simplifying things. That's good. And we have, we can flip those around. We can switch the order, which I'm going to go ahead and do, so they look the same. Now, again, these here, they don't look the same, but the only reason they don't look the same is because we're adding in different orders. The commutative rule of addition tells us that a plus b is the same thing as b plus a. So negative 2x plus 1 is the same thing as 1 minus 2x. So here I just flipped it around, you see. So don't get confused by all this. And the reason I flipped it around is so it looks like this other expression. So now we have a yellow 1 minus 2x, and we have a green x, and we have a blue 4, and we also have, to make things even more complicated, we have a purple 3. So we need all of these fractions to have those elements. So over here we have a 4x and a 1 minus 2x, but we don't have a purple 3. So we're going to have to multiply both sides of that equation by 3, and I guess I should just use purple. Multiplying both sides. Probably parentheses is the best thing to do, but I'm just going to use dots. So we're multiplying both sides by 3, and I guess I'll just change to parentheses. That's probably the best thing. Now the other fraction doesn't have a yellow 1 minus 2x, and it doesn't have a purple 3 either. So we're going to have to multiply by both of those things on both sides. It's kind of hard to keep track of all these colors, so I'm just gonna make those orange. On this last fraction here, we have a purple 3 and a yellow 1 minus 2x, but we need an x and a 4. So I'm going to multiply both sides by 4x. And there are faster ways to do this, but the problem with the faster ways is that it requires less, you have to do more of it in your head, and so it can be more difficult to understand. So now we have 3 over 12x, 1 minus 2x, and over here we have 3 times 1 minus 2x, and again 3 times 4 is 12x, 1 minus 2x equals 2 times 4 is 8, x times x is x squared, 4 times 3 again is 12, we have the x, and then 1 minus 2x. So obviously we're going to have to find some more space here, but you see that the important thing to understand is that these orange denominators, they're all the same now. So that suggests that we did this correctly. So I'm actually going to renumber this. I'm going to make this 15, and this other problem will make 14. So we'll get back to 14 when we finish this problem. So anyway, now we have common denominators, and we have to distribute here. And just to avoid confusion, I'm going to go ahead and do that and rewrite all this stuff just to show that one step. I know it's kind of annoying, but 3 times 1 is 3. 3 times negative 2x is negative 6x. You don't have to show quite this many steps. You do have to show some work, but you don't have to show all these steps. I'm showing more steps than you would probably have to, just because I want you to know exactly what's happening. But again, you should be doing these problems much quicker when you actually take the test. So now, like I said, if you're going to make a mistake, it's probably going to be here because you're subtracting that fraction. So we have common denominators, so we can add those, but instead of a positive 3, it's going to be a negative 3. Instead of a negative 6x, it's going to be a positive 6x. You have to be very, very careful. Now we have two fractions. We combined the fractions on this side because we had a common denominator. And now we have two fractions that are equal, and the denominators are equal. So that means that we can just get rid of the denominators. And 3 minus 3 obviously is 0, but I'm just going to go ahead and write it, I guess. We're going to get rid of the denominators. Now, remember, sometimes we run out of room. 3 minus 3 is 0. 6x equals 8x squared. So if we run out of room, we just have to use an arrow and go up here. So now I'm going to subtract 6x from both sides because we prefer a positive x squared coefficient, positive 8 instead of negative 8. And then I get negative 6x. And at this point, a lot of students would get stuck. In fact, at this point, a lot of students would get stuck. They would say, well, I don't know what to do. Maybe I'll divide both sides by x or something. But this is a problem where we have to put everything on one side of the equation and then factor out the GCF, greatest common factor, and that's going to be 2x. So 2x times 4x is 8x squared, and 2x times negative 3 is negative 6x. So now, if 2x is equal to 0, then that makes the equation work. And if 4x minus 3 is equal to 0, that makes the equation work. So what x value makes 2x equal to 0? Well, 0. And what x value makes 4x minus 3 equal to 0? If you solve that equation, you get 3/4. And actually, before we rectangle these answers, we have to check and make sure that they don't make the denominator 0 on the original equation. So these are the possible solutions, 0 and 4/3. Now if we go up here to the original equation, if we plug in 0, do we make any of the denominators in the original equation 0? And the answer is yes. If we plug in 0 here, we get 1 over 0. If we plug in 0 here, we get 1 over 0. So you're not allowed to have 1 over 0. So remember, when you have an equation with fractions, you have to plug in your solutions to make sure that it doesn't make 0 in the denominator. Remember, if you have 0 in the numerator of a fraction, that's okay. For example, 0 over 5, that would be 0. That's perfectly fine. Nothing wrong with that. But if you have 5 over 0, that creates a problem. That doesn't have any meaning. So we're not allowed to have that. So 0, because it makes 0 in the denominator, you plug in x, you make 0 in the denominator, that's not a solution. But 3/4, if you plug that in, that's not a problem. That doesn't make a 0 in the denominator anywhere. So our solution is 3/4. So now, again, I renumbered these, so I'm going to go back to 14 here. So now we have an equation with a square. We already solved one of these, but this is an easier equation, so we have to isolate that square. So see if you can isolate the square, and after that you're going to square root both sides. Remember to write your plus or minus, and when you come back we'll do it together. If you're not quite sure what I mean, we're going to add 23 to both sides, and we get 27 is equal to 3x squared. And then we're going to divide both sides by 3, and we get x squared is equal to 9. So now we're going to square root both sides to get rid of that square, but you have to write a plus or minus on the side opposite the variable. And usually I color those square roots. I don't really need to, but I guess I'll just keep with that procedure. So now that gets rid of the square. We have x is equal to plus or minus, what is the square root of 9? What number times itself is equal to 9? Well, that's just going to be equal to 3. And so that's it. You could just leave it like that if you wanted to. In fact, I'm just going to leave it like that. Well, probably should just break it up. So x is equal to 3, or x is equal to negative 3. But you can write it in either form. You can write it like this and just leave that rectangled, or you can break it up. In this example, it's easy to just write the different numbers. So if you got that one right, good job. Again, the biggest mistake students make is forgetting to write that plus or minus sign. So now we're going to solve an equation with fractions again. You want to get a common denominator, add all the fractions together on either side, Then you have two fractions equal with the same denominator, and denominators go away, so on and so forth. But make sure that your solutions don't make 0 in the original equation. Solve number 16, and when you come back, we'll do it together. All right, we're back. So if you're not quite sure how to do this, or if you got stuck, that's okay. This is calling out to us. We need to factor that, you see. So that's the difference of two squares. We have a perfect square here, and we're subtracting them, so it's going to be difference of two squares. We're going to need two sets of parentheses. What number times itself is equal to 25? That's 5. And what number times itself is equal to 6? That's going to be, or 36, that is, that's going to be 6. And we need a plus or minus, plus and a minus. And we need our b's, of course, on the 5s, because we have 25b squared. And so that tells us what we need to do to get a common denominator. So I'm going to multiply both sides of this equation by 5b minus 6. And both sides of the other equation by 5b plus 6. And students, almost in every case, when students learn this, they're gonna forget to put these blue parentheses here. Notice how I added parentheses there. There were no parentheses up here, but I had to add those parentheses because you're multiplying the entire red 5b minus 6 and the entire purple 5b plus 6 into that. Okay, so on the other side of the equation, I don't need to do anything to the other fraction because we already have the denominator that we need. So now let's go back over and double check everything. Everything looks good. If you write one wrong thing, it throws everything off. So you really have to go back and double check. So now we're going to distribute. 2 times 5b is 10b. 2 times negative 6 is negative 12. And 5b plus 6 times 1, that's just going to be 5b plus 6, of course. We're going to rewrite this. So now on the left side of the equation, we have denominators that are the same. Actually, all these denominators are the same now. That's our objective. And if you're starting to understand how to do this, take over on your own. Again, don't watch me do the whole thing. So now we can add the fractions at the left because they have common denominators. So we have 10b plus 5b is 15b. Negative 12 plus 6 is negative 6. And we have two fractions that are equal to each other. And again, the denominators are the same. So that means we can just get rid of the denominators. If the fractions are equal and the denominators are the same, then that means that the numerators must be equal. That's the only way that could possibly work. So now subtract b from both sides, add 6 to both sides, and we end up with b is equal to 13 over 14. So now if we plug in 13 over 14 into any of these denominators, are we going to get 0? And it doesn't look like we are. We'd have to plug in 6/5 or negative 6/5, and that would make the denominator 0, but we don't have that. So that's the solution. So if you got that answer, good job. On to number 17. Gold is too soft to be used as jewelry, so it's mixed with silver. If gold costs $1,800 per ounce and silver costs $30 per ounce, how many ounces of each metal would you have to mix to make 60 ounces of a gold and silver alloy that costs $1,003.50 per ounce? So alloy means a mixture of two different metals, in this case gold and silver. So the first thing we need to do is figure out what our variables are going to be. And what the question is asking, that's what our variables are going to be. How many ounces of each metal would you have to mix? So We'll let G be the number of ounces of gold, and we'll let S be the number of ounces of silver. Now let's see if we can come up with an easy equation. Usually we can find an easy equation, and the easy equation is going to come from this 60 ounces. We're looking to make 60 ounces, so we're going to combine our silver and our gold. Number of ounces of gold plus the number of ounces of silver, because we're mixing it together. When we mix it together, we have to have 60 ounces because it said it right here, you see. So now what's our other equation going to be? The other equation is going to be the harder one. This is the one where students really have some trouble. The gold silver alloy is going to cost $1,003.50, and we have 60 ounces of that. So we can just multiply 60 times that number. So 60, and maybe I should move this over a little bit. 60 times 1003.5. That's going to be the total amount of money that our alloy is worth. So you need to figure out how to calculate how much how would you figure out how much it's going to be worth? You would take the cost per ounce of gold, the cost per ounce, and you multiply it by the number of ounces of gold. So that's all the money that you're spending on gold. And maybe I'll keep that, yellow for gold. And then you multiply $30 times the number of ounces of silver. And I don't think I have a silver, or maybe I do. I guess I can pass for silver. And so that's the amount of money you spend on silver, $30 times however many ounces of silver you're using. So you add those up and you should get, 60 ounces times $1,003.50 per ounce. That gives you the total amount. So I know this is kind of a, advanced problem, it seems. But anyway, all we have to do is just solve that system. Go ahead and multiply 60 and that big number. So you can use your calculator to do this. You're allowed to have a calculator on this test, as long as you're not using your phone to go on the internet. I don't really want you to use your phone for a calculator, to be honest with you. You should just be using a scientific calculator or just a basic calculator that you have it, in your kitchen drawer or desk drawer. So we multiply those, and we get that number there. And now we just have to solve like we normally would. So do we use substitution or elimination? We never use graphing unless we're forced to. We use substitution if one of the letters is by itself on one side of the equation, but it's not. So obviously we're going to use elimination. So we can eliminate G or we can eliminate S. It wants to know how many ounces of each to use, so we don't really need to choose one or the other. So I'm just going to try to eliminate S because the numbers are going to be smaller. So I'm going to take that system, I'm going to multiply the top equation by negative 30. So then we're ready to add those together, cancel out the S's, and we get 1770G plus 0. And you can do this part in your calculator if you want to. 60,210 plus negative 1800 is equal to 58,410. And then that just simplifies. The 0 goes away, obviously. Again, you can skip some of these steps. You don't have to show everything. 58,410 divided by 1,700. And G is equal to 33. So we have 33 ounces gold. That's one of our answers. So now we're going to take this blue equation to find the number of ounces of silver. So we plug in 33 ounces of gold plus S is equal to 60. Subtract, and we get S is equal to 27 ounces of silver. And there you go. So if you got those answers, good job. So we just took this purple 33 and we put it into there. All right, on to number 18. The Smith family and the Thompson family are going to see a show together. The Smiths bought 3 adult tickets and 5 child tickets for $155. The Thompsons bought 4 adult tickets and 2 child tickets for $132. What is the price per child ticket? So this is just another type of problem that we just did, but this one's a little easier, I think. First thing we need to do is define variables. To do that, we need to figure out what it's asking. So it says, what is the price per child ticket? So that's what our variables are going to equal. C is going to be the price per child ticket. And we'll let A be the price per adult ticket. Now the difference is we're not talking about the number of ounces or the number of tickets sold. We're talking about the price per ticket. So be aware of that. Okay, so if you want to figure out how much it's going to cost for the Smiths, you have to take the number of adult tickets that they bought and multiply that by the price per ticket. Then you have to add the cost for child tickets, which is the number of child tickets they bought times the cost per child ticket. And that should equal the total cost that they paid, which we're told is $155. So just to be clear, this 3 came from there, and this 5 came from there. And of course the 155 came from there. So now the Thompsons, they bought 4 adult tickets. So we're gonna 4 times the cost per adult ticket, and they bought 2 child tickets, so 2 times the cost of the child tickets. Add it all up, and they paid a total of $132. So we can use this equation to help us solve. I'm not going to do colors for the bottom equation because I don't have enough colors. So let's just double check, make sure that's all right. It's pointless going forward if you don't make sure that the numbers are correct. Okay, so we have to decide, what are we going to eliminate? Well, we're looking for the price per child ticket, so we want to eliminate A, because if we eliminate A, then we'll have the price per child ticket. We won't have to do any more math. So I'm going to copy down this equation. Maybe I'll use my program to just copy that so I don't have to rewrite it. So I'm going to copy that same equation, and I'm going to multiply the top equation by -4 and the bottom equation by +3. Now you could do +4 and -3. It doesn't matter as long as one's negative and the other is positive. So now we end up with -12a minus 20c is equal to, and you can use your calculator for this because these numbers are kind of big, 4 times 155, -4 times 155, that's a -620. 3 times 4a is 12a. 3 times 2c is 6c. And 3 times 132 is 396. So now we're ready to eliminate. So we add those up. You get 0 plus -14. Maybe I should just write minus 14c. And -620 plus 396 is equal to -224. But of course we're out of room, so we're going to go up. Don't panic if you run out of room, just use an arrow. So divide both sides by -14, and we get $16 per child ticket. And that's all we're looking for is the price per child ticket. So we don't have to find the price per adult ticket. So if you got that answer, good job. Okay, number 19, graph the following equations and identify the slopes. So we're going to label our axes. Don't forget to label your axes. And x is equal to -7. So I'm going to make this 8. And so -7 would be somewhere around here. That's a vertical line. X equals, when it's x equals, it's always vertical. And before I forget, we have to write the slope. Remember, the slope is always undefined. You can write UND or you can write undefined. It doesn't really matter. I don't really care. So now y is equal to 4. And again, your graph doesn't have to be perfect. You might be asking, well, how come you don't give us graphing paper on this problem? It'd be a lot easier if we had graphing paper. Well, sometimes you have to graph something without graphing paper, so I want you to get used to that. All right, and the slope, of course, if you have a horizontal line, the slope is always 0. So be sure to rectangle your slopes. That's part of the answer. So if you got those answers, good job. On to the next problem. Okay, so we have an equation with fractions. And again, remember, you always want to factor. That's the first step, so we can find a common denominator. So factor this quadratic. We have 2 and 4. Factor this GCF. Y is common to both those terms. And we're going to factor a GCF, and we end up with y squared plus 6y plus 8, and that kind of looks familiar, right? This blue expression here looks familiar to that. And unfortunately, we are going to have to rewrite that whole thing just to show that we're going to factor that quadratic expression that was left in the fraction at the right. So rewrite that whole thing, but we're going to factor to y plus 2 times y plus 4. And so all we did was just factor the denominators. We factored the yellow, and we factored the purple, and we factored the green. All right, so now that helps us to find a common denominator. So we don't have time to do a lot of colors here, but, and you know, I should probably get rid of these colors because I didn't use them in this exact way before. So we need to make sure that each one of these fractions has a yellow, a purple, and a blue. So I'm going to multiply both sides of this fraction by y. And we're running out of time here, so I'm just going to go ahead and rush forward here. So I'm going to multiply both sides of this fraction by y times y plus 2. And we're going to multiply both sides of that other fraction by y plus 4. And we don't have to multiply the last fraction by anything because it's already got a blue, a purple, and a yellow. And I'm not really showing the actual multiplication, or I'm kind of rushing forward a little bit here because we're kind of running out of time here. I don't want this class to go too long. So let's go back and double check, make sure we did everything correctly. And so now we want to simplify. So we get y squared. Well, I'm just going to kind of rush forward here because, again, we're running out of time. So I get y squared plus y times y plus 2 plus y plus 4. And over here we have 24, and we still have our denominators. So I went ahead and combined all this to one fraction. Again, I'm kind of not showing every single detail here. I'm kind of jumping forward a little bit because we don't want this class to go too long. Alright, so now we can get rid of the denominators, and we're left with y squared. I'm going to distribute there. We have y squared plus 2y plus y plus 4 is equal to 24. Y squared plus y squared, that is equal to 2y squared. 2y plus y is equal to 3y. And put the 24 on the left side of the equation, and we end up with negative 20 is equal to 0. So now we have a quadratic. And normally we would just ask, well, what two numbers multiply to negative 20 and add up to 3? The problem is, in this situation, we have a coefficient on the y squared term, and that makes things more complicated. So now we have to first ask what two numbers multiply to 2, and that would just be 2 and 1, so I'm going to put 2y and y. And then we can ask what two numbers multiply to negative 20, and I'm going to say positive 4 and negative 5. And I think that's actually going to work. Now we have to do FOIL, so F, O, I, L. 8y minus 5y is 3y, and we got our yellow 3y. That's what we're looking for, so I got lucky on that one. I got the right one on the first try. So now, in order to make that equation work, 2y minus 5 has to be 0, or y plus 4 has to be 0. Solve that equation and we end up with y is equal to 5/2, or y is equal to negative 4. Now again, we have to go back and check to make sure that neither of our answers make zeros in the denominator, but you see up here, this green here, if we put it inside that fraction there, it makes 0. So that's, we can't have 0 in the denominator, so that's not equal to negative 4. But y equals 5/2, that's completely fine. That's one of our solutions. So if you got that one right, good job. That was kind of a doozy, a big problem. Now we're going to try another fraction. So we want to change the 2 into a fraction, because we're always going to have to deal with combining the fractions in these equations with fractions. And we're going to factor the denominator. What two numbers multiply to negative 10 and add up to 5? Well, that's just going to be, or add up to 3, that is. That's going to be 5 and negative 2. And we don't have to worry about, the complications there, because there's no coefficient on the b squared term. So now we kind of see what the denominator is going to be. So I'm going to have to multiply. Maybe I should use different colors this time. I'm going to have to multiply both sides of this equation by this orange expression here, because we have a yellow 5 and a green b minus 2. And we need those common to all the denominators. So in this next fraction, I have a b plus 5, but I don't have a b minus 2. So I have to multiply both sides by b minus 2, and be sure to use as your parentheses. Students typically don't write enough parentheses. In the next fraction, I have b minus 2, but I need a b plus 5. So I'm going to multiply both sides by b plus 5. And we already have everything we need on that last fraction. So over here, we're left with 2, and probably the best way to do this is to go ahead and multiply FOIL. So that just gets us back to the expression we had before. And then we're going to multiply by 2. There's different ways to do these problems, and I'm not using the shortest way when I do these problems because the short way usually requires you to do problems in your head. I'm going to distribute that, so that would be 2b plus 10. And again, the problem with doing things in your head is that how are you going to show students how to do it if you're doing it in your head? You know, I'd like to do all these problems in my head, but how does that help you? You know what I mean? So even though it's taking me a lot longer, you know, you can skip some of these steps and you can do a lot in your head. You don't have to show all of this, but you know, don't get too out of control. I mean, a lot of students, they don't show anything. You have to show some work. Okay, so now we know we have a common denominator in all this stuff, so I'm going to go ahead and distribute and combine to one fraction. Again, I'm skipping a few steps. So we've got a big fraction there. Over here, this fraction doesn't change. And trust me, this is the long method. There are methods that are way faster, but again, it requires you to do more in your head. So now we're going to add all these terms up, so we get 2b squared. 6b plus b is 7b plus 2b is 9b. And negative 20 minus 2 is negative 22. Negative 22 plus 10 is negative 12. And then we get b squared plus 6b minus 2. Subtract b squared. This is a special equation. It's a quadratic, so subtract b squared from both sides, so we get a coefficient, positive coefficient on the b squared term. Subtract 6b, and we get 3b. And add 2, and we get negative 10. And it looks like this is going to be a nice, neat quadratic. You have to recognize it as a quadratic, and you have to put it in standard form. If you don't do those two things, then you got no hope. No hope whatsoever of solving this problem. So now we can factor it, and there's no coefficient on the b squared term, so we can just write b and b and ask what two numbers multiply to negative 10 and add up to 3. And that's just going to be 5 and 2, which is the same thing that we got. You know, that's the common denominator, so that's probably going to create a problem. If b plus 5 is equal to 0, then that makes the equation work. And if b minus 2 is 0, that makes the equation work also. So the b value that would make b plus 5 equal to 0 would be negative 5, and the b value that would make b minus 2 equal to 0 would be 2. But here's the problem. If you take these purple numbers and throw them up in those denominators, those original denominators, plug in negative 5, and it's going to make the denominator up here 0. If you plug in this blue 2, up here it's going to make the denominator 0. So this is a rare situation because both of our solutions were extraneous. So what that means is there are no solutions. You can use plural or singular. Doesn't really matter. Okay, so there you go. If you got that one right, good job. We're going to have to hurry here because we're going a little overtime. Actually, we're going a lot overtime, but again, these practice tests, I'm trying to explain every problem. Bill has 32 coins in his pocket, only quarters and dimes, so obviously we know how many of each type of coin does he have. Try this problem on your own, don't just watch me do it. Q equals number of quarters, and D equals number of dimes. We know that from here. That tells us what our variables are going to be because it's what the problem is asking for. Remember, there's usually a really easy equation. The easy equation is there's 32 coins. So the number of quarters plus the number of dimes is obviously going to be 32. You know, Don't complain until you get at least that problem or that equation written, because that's easy. So how are we going to figure out how much money is in his pocket? Well, we know how much money is in his pocket, so we'll just write $5.90. But how would we calculate that? Well, we'd take the number of quarters and multiply it by 0.25, because 0.25 is the value of each quarter. That would give us the amount of money he has, the value of his money in quarters. But then we'd multiply 0.1, because that's the value of each dime, and multiply that by the number of dimes, and that gives us, the value of his coins. So now we have a system of equations. You know how to solve this. You've done it multiple times. Both these equations are in standard form, and so I'm going to multiply. I can get rid of Q or D. I think I'm just going to get rid of D because the numbers are easier. So I'm going to multiply both sides of the top equation by negative 0.1. And then we end up with negative 0.1 Q minus 0.1 D equals negative 3.2. And then if we add those up, we get 0 here, and we get 0.15 Q. We get 270 here. You can use a calculator if you need to. So now we're going to divide both sides, because we get 0.15 Q is equal to 2.7. You can use your calculator. 2.7 divided by 0.15 equals 18. So we have 18 quarters. And then you can just take this equation up here, and we have 18 quarters. So how many dimes do we have? Subtract 18 from both sides, and you get 14. So we have 14 quarters. And we should probably put units. So I'm going to just say quarters. I don't think I'd really care on this particular problem, because obviously Q is equal to quarters, so it's kind of just assumed. So 14 dimes, and we're done. So we found those answers. If you got that, good job. Okay, on to number 23. For each graph below, write an equation of the line shown and identify the slope. So if you can do 23A, go ahead and do that problem. This is a vertical line. So whenever you have a vertical line, the equation is just going to be x is equal to wherever it's centered at, and that's negative 2. And the slope is always undefined. You can just write UND if you want. So those are the solutions. If you got that right, good job. Part B, we have a horizontal line, so it's always y is equal to wherever it's at, and that's 1. And the slope of a horizontal line is always 0. So there you go. Pretty easy. So if you got those right, good job. So over here, the first question we're going to ask is, can we use slope-intercept form? We can only use slope-intercept form, that is y equals mx plus b. We can only use that if we know the y-intercept. Remember, the b is y-intercept. So do we know the y-intercept? And if we look at this area here where it crosses the y-axis, we don't really know the y-intercept because it doesn't look like it's crossing in a place where we can really see. But over here, we can use the y-intercept because it crosses at 1, you see. So we can say that that point tells us that b is equal to 1. We also can use a triangle. We can go down 1, 2, 3, 4, 5, and then over 1. So the rise is 5 and the run is 1, so that's 5 over 1. But be aware, it's going down, so it's going to be negative 5 over 1. Okay, so now that we have the y-intercept and the slope, we can write y equals mx plus b. So we have negative 5x plus 1, and we're done. And we identified the slope is negative 5 over 1. So if you got that one right, good job. I did the easy one first. Not that this one's really that difficult, but we can't use the y-intercept here, so we're just going to have to use a random point and the slope. So I'm going to use this point here, Doesn't really matter which one you use. And that's going to be -1, -1. So I'm going to write those coordinates. So -1, -1. And I'm also going to use the slope. So we go up 1, 2, and 1, 2, 3, 4, 5, 6, 7. So that's 2/7 going up. So it's a positive slope. So m is equal to 2/7. Then because we have a point in the slope, we can write point-slope form. So y plus, remember the signs change, plus 1 equals 2/7 x plus 1, because again, the signs change to positive. That's just something you're going to have to memorize. And the slope is 2/7. Remember, the slope is part of your answer. So if you got those, good job. All right, sorry we're kind of rushing through this a little bit, but this class is going a little long. All right, a bird drops a stick. If we neglect air resistance, the height in feet of the stick t seconds after the drop can be modeled with the following equation. So the bird's just dropping a stick, and the height of the stick is equal to h. Find the height of the stick 1 second after the bird drops it. So h is equal to -16, plug in 1 for t, because it says 1 second, t is the number of seconds. Then we get h is equal to -16 times 1 plus 60, and h is equal to -16 plus 60, and that would be 44 feet. So if you got that one right, good job. Part B, how many seconds, again, try these problems. If you think you can do these problems, do them on your own. How many seconds after the bird drops the stick will it be 30 feet above the ground? So now we're given h is 30. So now this is an equation with a square. It's not a quadratic. We have a t-squared term, but we don't have a t term. So we just have to isolate this square, you see. So let's get that square by itself. Subtract 60 from both sides. Divide both sides by a -16, and we have 30 over 16. Reduce that, and we get 15 over 8. But then we have a square. So we found t squared, but we don't want t squared. We want just t. So we have to square root both sides. And remember, you always write a plus or minus on the side opposite the variable. The square root gets rid of the square. And over here, we can't leave it in that form, so it's going to be root 15 over root 8. But remember, root 8 is 4 times 2. So we have plus or minus root 15 over 2 root 2, because a 4 comes out as a 2. And then multiply both sides. And I'm going to get rid of this step because we don't really have enough room. And you can pretty much do all that, a lot of that in your head. Multiply both sides by root 2, and we get root 30 over 4. And you can't have a negative time, negative seconds, so we're just going to leave it like that, and we have to write our units, s for seconds. So if you got that answer, good job. Okay, how many seconds after the bird drops the stick will it hit the ground? So now we're talking about hitting the ground. So h is going to be 0. And we just solved the same equation again. The only difference is h is 0. So subtract 60 from both sides. Solve for t squared. Divide both sides by -16, and we have t squared is equal to -60 over -16. And so now we have 30 over 8. And that simplifies even more to 15 over 4. So I'm just going to go to 15 over 4. As usual, we square root both sides. Be sure to write a plus or minus, even though we're not going to have a negative solution. And that just equals a square root of 15 over 2. And remember to write seconds. We need our units for these word problems. And that's it. 15 over 2, root 15 over 2 seconds. So if you got that answer, good job. Okay, how many seconds after the drop will the stick be 10 feet above the ground? All right, so now we're plugging in 10 to h. Subtract 60 from both sides. Divide both sides by negative 16, and we get 50 over 16. Reduce that fraction, and we get 25 over 8. And square root both sides. Be sure to write a plus or minus. So square root 25 is 5, and square root 8, we'll just leave that as square root 8 for now. Square root 8 turns into 2 root 2, right? Again, this is just all review. Now we're going to multiply both sides by root 2, and we end up with 5 root 2 is equal to, or over 4. And we can't forget our plus or minus symbol, even though the final solution is not going to have a plus or minus, because there's no such thing as negative times. So if you got that answer, good job. So that was good practice in roots. Okay, on to this last problem here. Mr. Benson's address is written on a flat rectangular sign hanging from his porch. The numbers are written on a smaller rectangle at the center of the sign. The area of the entire face of the sign is 96 square centimeters less than 3 times the area of the inner rectangle containing the writing. If the length of the inner rectangle is 28 centimeters shorter than its width, what are the dimensions of the sign? So if you think you can do this, go ahead and try. Now we have to write our master equation. Our master equation deals with area. So I'm going to say the total area is equal to the, I'm going to say the inner area, or maybe I can, well, maybe not. Let's see, so where's our master equation? It's this yellow here. The area of the entire face of the sign is 96 square centimeters less than 3 times the area of the inner rectangle. So we want 3 times the area of the inner rectangle. So I have to multiply that by 3 and then subtract 96, because it says 96 square centimeters less than 3 times the area of the inner rectangle. So I stands for inner rectangle there. So that's where that master equation came from. So again, you can look back at that, stop the video, and make sure that's correct. So now we need some special x values. I'm going to use maybe purple, something that'll show up. And I'm going to have to go over here because I don't want to mess my picture up. So I'm going to draw the inner rectangle here. 5554 Lake. And so we have, if the length of the inner rectangle is 28 centimeters shorter, so that means if this is x, then this would be x minus 28. So what that means is the area of the inner part, that would be, and I guess we can use brackets maybe, that would be the width times the length. Remember, area of a rectangle is length times width. And then the total area, well, that's going to be x, this value here in purple, that's x. But then we have to add 8, and we have to add 8 over here also. So that's the total. We're looking for the total area of the whole thing. So we have x plus 8 plus 8. That's the width of the whole sign, everything, even the green part. So now we're going to multiply that by the length. The length is x minus 28, which is this part here, right? This purple part here. But then you have to add 6 to get the whole length, or the whole length. You have to add 6 twice. So I have to get rid of that parenthesis, and I have to add 6 plus 6 plus 6. So again, very important to understand that this here, that's the total area, and this is the inner area. All right, so kind of hard to keep track of all these different types of highlighting. So now we're going to simplify. We end up with x plus 16 times x minus 16 equals 3x times x minus 28 minus 96. Whoops, I forgot a parenthesis there. And so then we can distribute here with 3x times x is 3x squared. 3x times negative 28 is negative 84x. Then we're going to multiply there. X times, we have to FOIL, so x times x is x squared. X times negative 16 is negative 16x. 16 times x is 16x. And 16 times negative 16, that's going to be a big number. We can use a calculator for that. But I think it's going to be negative 256. 16 times 16 is, yeah, 256. So now we're going to, we want a positive coefficient. We're going to subtract x squared from both sides. And then we're going to cancel these out here. They just kind of go away. I'm going to we'll put our negative 84x and then add 256 to both sides. If you combine that to 96, we get 160. So we're putting this is a quadratic equation. Again, it's so critical to recognize it as a quadratic. If you don't recognize it, then we've got no hope. So then at this point, I'm going to do something that's going to kind of help us simplify this quadratic. I'm going to divide by 2. And why am I going to do that? Well, because 2 goes into all those numbers, so you can divide a polynomial by a monomial as long as each term in the polynomial has factors, has a factor the same as the monomial. So 0 divided by 2 is 0, and then we get x squared minus 42x plus 80. And I'm going to factor that. It's a quadratic in standard form. What two numbers multiply to 80 and add up to negative 42? Now that's not going to be easy. The numbers are probably going to be pretty far apart. I'm going to try, we could try 20 times 4, but that doesn't work. You add those up, you get 24. So the numbers have to be farther apart. So we could try 40 times 2, and bingo, that's going to be it. 40 times 2 is 80, and add them up, you get 42. But they have to be negative. So negative 40 times negative 2 is positive 80. So what that means, and let me find some more room here. So if x minus 40 is 0, that makes the equation work. Or if x minus 2 is 0, that makes the equation work. And we're going to have to go up here because we're completely out of room. So obviously x value that would make that equation work is 40, or x is equal to 2. Sorry for the mess here. So now one of those answers is probably going to be extraneous. If you plug in 2 to x, look at this. Look at this blue stuff here. You plug in 2 up here, and what do you get? 2 minus 28 is negative 26. You can't have a negative 26 length. So 40 is going to be the answer. X cannot be 2. Or it's going to help us find the answer. So then we plug in. So what are we at? It says what are the dimensions of the sine? So that's the whole thing altogether. So we need to find the length of the entire sine and the width of the entire sine. That's the width, and then the length of the entire sine is up here. So that's what we need, and that's going to be these yellow expressions here. So we have the length, which is equal to x minus 28 plus 6 plus 6, and we know x is 40, so 40 minus 28 plus 6 plus 6, and so that equals 24 centimeters, so that's the length, and the width, that's equal to x plus 8 plus 8, so 40 plus 8 plus 8, which is equal to 56 centimeters. And there we go. That's it. So we found the, because it says find the dimensions of the sign. So that means what is the width and the length of the entire sign. So that was the class today. Things kind of intensify when you get close to the end of the course. So get a screenshot of this page if you want to use that to study for your test. Screenshot number 2. And screenshot and screenshot number, next screenshot, and next screenshot, and next screenshot, next, and next screenshot, and the last screenshot. But don't go before you get your homework. Let's take a look at the homework. So get screenshot number 1 of the practice test for homework, screenshot number 2, and screenshot number 3, and number 4, and number 5, and number 6, and number 7, and number 8, and number 9, and number 10. But don't go before you get to the answers. You need the answers to the homework. It's not enough just to attempt the homework. To attempt the practice test, you have to get the answers right. So here's screenshot number 1 of the answers. And screenshot number 2. So get that practice test done. And remember, if you want to get an A in the test, the practice test is not enough. To get an A in the test, you actually have to go back and make sure you know how to do all the problems that we did in the second half of this course, and even some problems from the first half. So I'll look forward to seeing you in the next class.